Hello dear students, now that we have studied the test cross in this module, let's have a better understanding about what exactly is a back cross. As in the last module, we already studied that a test cross can also be called as a back cross. So students, I can very well say that a cross between F1 generation and a homozygous tall parent can also be called as a test cross or a back cross. But students, here in this case, the progeny that is produced is all tall plants. Now in such a situation, I know that 50% can be hybrid tall, whereas the remaining 50% would be pure tall. But then this makes it very difficult to understand the genotype of the F1 hybrid. As a result, I can never use or I cannot use the dominant trait as a back cross. So as we have studied, a test cross is something that has to be done with the help of a homozygous recessive parent. Further students, when we talk about a test cross, as I said, a test cross can always be a back cross, but a back cross is not necessarily going to be a test cross. So I hope now you understand the difference between a test cross and a back cross better. Further students, a test cross can be studied very well with the help of an example. Let's say test cross, as we know, is something that is used to study the genotype or to know the genotype of an unknown genotypic dominant trait. Let's say here I have a violet colored flower producing plant which is a dominant trait, but then its genotype is unknown. In such a situation, what I can do is I am going to cross it with a recessive flower, which is a white colored flower. And if the progeny that is produced is all dominant or all violet flowers, then that case I can say that the dominant trait was a pure trait or a homozygous trait. But if when I produce a cross between a pure dominant trait and a recessive trait, if the progeny that I get is 50% dominant violet flower and 50% recessive, that is white flower, that is the violet and the white in the ratio 1:1, then in that case I can say that the dominant trait used here was a heterozygous dominant trait. So students, now you know how exactly can test cross be useful in understanding the unknown genotype of a homozygous or a heterozygous dominant trait. Further, now let's see the significance of the test cross. Students, test cross is something that can be extensively used so as to incorporate any recessive trait, rather useful recessive trait, in crop improvement programs. Also, as you know that the test cross ratio 1:1 is a very simple ratio and it is most common or most famous amongst the plant breeders. So hence, now you know the significance of test crop and why it has to be incorporated. So students, in this particular module, we are done with the back cross, and now let's see the graphical representation of the test cross in our coming module. This is for your better understanding. Thank you.